my dear PU2 warriors, welcome to Diksha Karnataka YouTube channel, and today I am going to help you with the solutions of all important questions that might come in your FA2 exam, right? This video exclusively is for PU2 students, and obviously as you all know I teach physics, so I am going to discuss the complete question and answer of PU2, all important questions of your FA2 chapters. But before I start, just let me tell you that if you have not yet subscribed to our channel, if you are watching this channel for the first time, please don't forget to subscribe to our channel and obviously join the WhatsApp channel. The link of the WhatsApp channel is given in the description of the video, and you will get the PDF of the entire lecture as well as all the series that we are doing, but that will be available only through our WhatsApp channel. So don't forget to join the WhatsApp channel, right? So let us start. What are all the chapters that we are going to cover today? So according to the syllabus of FA2, the chapters are alternating current, electromagnetic waves, ray optics and wave optics. If you have any other chapters in your FA2 exam, please mention that in the comment section below, right? We will try to cover that in our upcoming videos if possible, right? So please don't forget to mention that in the comment of this video that sir, I have this chapter, and I will try to make it covering up those chapters in some future videos. Now let us see, so what will be the pattern of today's lecture. So first we will be discussing 20 complete MCQs, okay, and 5 fill in the blanks. So that will be there. So 20 MCQs from all the chapters combined, okay, total 20 MCQs and 5 fill in the blanks, again all the chapters combined. Then we will be discussing important questions chapter wise. So after the MCQ and fill in the blanks are over, then you will get the chapter wise questions and their answers, right? Now let's start. Different devices connected to an AC source are listed in the first column, and different phase relations of the electric current with the voltage are listed in the second column. Choose the correct match. Now this may not, the exact question may not be coming, but the phase relation related question will be coming. There is a high chance that phase related questions will come in your FA2 as well as your pre-board as well as your final exam. So you should remember all the phases. For example, resistor, in case of resistor, current and voltage always stay in the same phase, so a resistor is in the same phase with the voltage, right? Now what about inductor? In case of inductor, it lags behind, okay, inductor lags behind the current lags behind the voltage by pi by 2. So for a pure inductor, the current lags behind the voltage by pi by 2. In case of capacitor, capacitor current leads the voltage by a factor of pi by 2, right? So we found our correct match. 1 is matching with Q, so 1 is matching with Q, 2 is matching with P, and 3 is matching with R. So now let's find the correct match for this question. So 1 is Q, so 1 Q, 2 is P, 3 is R, so correct match here is option C, right? So remember the phase relation, that in case of resistor, all the voltage and current remains in same phase. In case of inductor, current lags behind the voltage by pi by 2, and in case of capacitor, current leads the voltage by a factor of pi by 2. Now let's move on. The resonance phenomena is exhibited by a circuit only if the following components are present. So resonant phenomena occurs only when the circuit has inductor and capacitor. Resistor does not play any role in resonance. Only thing that resistance plays is to control the current. Other than that, there is no such role of resistance. So L and C is the correct answer for this question, okay? In resonance exhibited by circuit only if the following components are present, L and C. Now next, the relation between peak value of IM and RMS current is, so RMS current is the peak value divided by √2. So correct answer is RMS equals to peak value by √2. This is the same relation valid for voltage as well, okay? So same relationship is valid if VRMS equals to I maximum by √2. Sometimes they might change the question, they will give you peak value and RMS, so you have to also remember that peak value value is equals to root 2 into RMS. So this is also another relation that you should keep in mind in case they change the question. Okay, now let's move on. An ideal step-up transformer decreases. Step-up transformer means it increases the voltage. Okay, so step-up transformer is something which increases the voltage. Now if something it has to decrease is basically current. Okay, if voltage is increasing, current has to decrease. Okay, if voltage is decreasing, current will increase. Vice versa relation. Okay, opposite relation. So ideal step-up transformer means it increases the voltage, then it can decrease only one thing, that is current. Okay, for ideal transformer, power remains same. Now let's move on. In a transformer, the windings of the primary and the secondary coils are wounded one over another to reduce the energy loss due to. So in transformer we have a primary coil which is connected to the source and a secondary coil which is connected to a load. For example, the light that you are using or the mobile phone that you are charging, that is basically your load. Okay, so when you generally you have seen the diagram of transformer like this, right? This is the typical transformer where one coil is like this, another coil is like this. Now this is not wounding one over another, they have a lot of gap between them. But when you have only single core and they are wounded like this, this happens to reduce the flux leakage. Okay, so that the flux that is coming out of the primary should always cross through the secondary. So this is a way to reduce flux leakage. So correct answer is option A for this question. We will see that in a while in a detailed manner in the long format questions. The frequency of X-rays, gamma rays and UV rays are A, B and C respectively. Then what is the relation? So you have to remember that the order, okay, order is first is gamma ray, next is X-ray, then we have UV ray, okay, then we have visible light, then we have infrared rays, then we have microwaves, and then radio waves. Okay, so this is the order of all the electromagnetic spectrum and radio. Okay, so this is the order of the electromagnetic spectrum, and the wavelength is smallest. This one has smallest wavelength, and this one has highest. This one has highest wavelength. But in case of frequency, gamma ray has smallest. Gamma ray has highest. Gamma ray has highest. And radio have smallest. Okay, so the relationship you have to remember, anything else is actually falling in between, okay, according to the order. So this is the order of wavelength, and they are asking you in terms of frequency. So which one has a frequency A? So X-ray has frequency A, gamma ray has frequency B, and UV ray has frequency C. So which one has highest frequency? So B is bigger than everything else. So B is greater than A, and A is greater than C. Okay, so this is the order. B should be greater than A, and A should be greater than C. So correct answer is option B. Remember this order. In terms of wavelength, gamma ray is smallest, radio waves is largest. In terms of frequency, exactly opposite, that is gamma ray is highest and radio waves are smallest. Don't get confused between frequency and wavelength. Okay, smaller the frequency, it has more penetrating power. That means it can go through objects easily. Okay, that's why gamma rays, X-rays, UV rays are harmful to human, because they can penetrate your skin and go deeper. Okay, so that's why they are considered harmful. But in terms of frequency, it is exactly opposite. So frequency of gamma ray is highest. Okay, X-ray is next highest, UV ray is coming third in the list. Okay, now let's move on. Speed of light according to Maxwell's equation is given by. So speed of light according to Maxwell equation is given by C equals to 1 upon mu naught epsilon naught. C equals to 1 upon mu naught epsilon naught is speed of light according to Maxwell's equation. Next, the angle between electric field and magnetic field in an electromagnetic wave. The angle between electric field and magnetic field will always be 90 degrees in case of electromagnetic wave. No other angle is possible for electromagnetic wave, so correct answer option A. Next question, according to generalized Ampere-Maxwell law, B dot dl. So according to generalized Maxwell's law, B dot dl equals to mu naught IC plus mu naught epsilon naught mu naught d phi E by dt. Okay, this is generalized Maxwell's law, and this one is only displacement current. Okay, if displacement current is asked, this is called displacement current. Don't get confused. Okay, same question, same options with different answer can be asked, saying that what is the expression for displacement current. Okay, they will give you this formula, you have to choose, then you have to choose option C. But if they ask generalized Maxwell's law, then this will be the correct answer. Okay, so keep in your mind that this is generalized Maxwell law, this is the expression for ID. These two equations you have to remember. Okay, now next, which of the following ray is absorbed by ozone layer? X-ray, gamma ray, UV ray, all rays are absorbed by ozone layer. That's why it is very, very essential for our survival. So option D, all of the above is correct answer. It does not only it absorbs UV rays, it also absorbs X-rays, it also absorbs gamma rays. Any high frequency radiation is generally absorbed by the ozone layer. Even some part of the violet rays is also absorbed by our ozone layer. Now next question, the angle of minimum deviation of a prism depends on refractive index of the material of the prism, refractive index of the surrounding medium, refracting angle of the prism. So if you remember, the refractive index of the surrounding with respect to surrounding is given by sine A plus delta m by 2 divided by sine A by 2. So if you see that, it depends on the refractive index of the material of the prism, refractive index of the surrounding of the prism, because it is a relative refractive index. Relative refractive index means generally if the surrounding medium is air, then we can say only n, but if the surrounding medium is not air, suppose it is water, then also this formula is valid. Only difference is in that case we have to take the relative refractive index. Okay, so it depends on the refractive index of the material, refractive index of the surrounding, refracting angle of the prism, because obviously A is also there in the formula, so definitely it depends on all three, 1, 2 and 3. So correct answer is option D. Okay, so don't ignore the surrounding medium. Surrounding medium is also important when it comes to refractive index. Surrounding medium is always there maybe it is present or not, but most of the cases, because we use air as our surrounding, so we tend to ignore this, right? So we tend to ignore this point because most of the cases our surrounding is air. But if the surrounding medium is not air, then you have to take care of this as well. Very important to remember. Now next question. Total internal reflection is possible when light is traveling from air to water, water to air, air to glass, all of the above. So total internal reflection is possible only when light is traveling from a optically denser medium to optically rarer medium. So for example, water is optically denser compared to air, so it is only possible when light is traveling from water to air in this particular case. Okay, so light has to travel from optically denser to optically rarer medium. Next question. Image of a real object formed by a simple microscope when the object is placed at a distance less than 1 focal length is. So you have a simple microscope means a simple convex lens. Okay, simple microscope is a simple convex lens. This is the focal length, say, and if you keep an object less than one focal length, the image it will form is a virtual and enlarged. So it will be virtual, erect and magnified. So correct answer is option B. Okay, that is why simple microscope are used. Simple microscope basically gives you a small magnification. Magnification is not huge, but still it gives you an enlarged, virtual and erect image. Okay, that's why they are used. Main reason is it is enlarged and erect, so you don't need to flip it. Okay, so you get the direct image. That's why they are used. Next, the lens nearest to object in a microscope is called, the lens nearest to the object in a microscope is called the object lens, the objective lens, the eye lens, the eyepiece. So the lens nearest to the object in a microscope is called the objective lens, not object lens. It is called objective lens. Okay. One problem with the reflecting telescope is that the objective mirror focuses light inside the lens, outside the telescope tube, inside the telescope tube, all of the above. So one of them, first of all, what telescope we are talking about? We are talking about reflecting telescope. Reflecting telescope means it uses mirrors. Okay, it is already mentioned in the question. So reflecting telescope uses mirrors. So definitely the lens is a wrong answer. So this is a wrong answer means all of the above should also be wrong. So either outside the telescope tube or inside the telescope tube should be an answer. Now if the image is formed outside the telescope tube, then we can place a screen, okay, or we can extend the tube if required, and we can observe a very good image. But if it is forming inside the telescope tube, then we have to use some special techniques. Okay, so that's why this is a problem, that the image is formed inside the telescope tube, not outside. Okay, so if you consider a concave mirror, which is a primary mirror or objective mirror for reflecting telescope, so light when it falls on this, okay, the telescope tube is like this. So the telescope tube looks like this, and after reflecting the light ray, actually reflect back and they form image inside the telescope tube. Okay, so that is a problem. Now there are some ways. One of the ways that was used by Cassegrain, he cut this pieces over here and he placed a convex mirror so that the light ray which are coming over this direction, they can go and meet at outside, and you will get a real image which can be observed through some screen. Okay, so that is one of the ways that was done by Cassegrain. Now modern day telescopes, they use a sensor over there, and the sensor transmit the data, small sensor which is mounted from the mirror. Okay, and then that sensor can transfer the data. That is one of the ways. Clear? So inside the telescope tube is a problem, outside is not a problem. If unpolarized light of intensity I naught is passed through a Polaroid, the intensity of the emergent light. When the unpolarized light passed through a Polaroid, okay, after polarization, the intensity of light becomes half. Intensity of the light becomes half, which is I naught by 2. Okay, it is a flat 50% discount. Okay, so Polaroids gives you flat 50% discount. So as soon as the light passes through the first Polaroid, the intensity becomes I naught by 2, and if there are more Polaroids, based on the angle you have to apply Malus law, that is I naught by 2 into cos square theta. But here only one single Polaroid is given, so the answer will be I naught by 2. Remember this, if you are preparing for KCT exam or maybe joint exam or NEET exam, this question, this concept is very important, because in that case they will give you multiple Polaroids. Okay, there used to be one time, except last year, for last 3-4 years almost, except last 2025 exam, every year there was a question based on this concept, okay, in KCT exam. Okay, so remember this. The phenomena of bending of light at the corners of an obstacle is called diffraction. It is called diffraction. Bending of light at corner is called diffraction. According to Huygens principle, the speed of the secondary wavelet is twice that of the wave, 0, same as the wave, infinite. According to Huygens principle, the secondary wavelet move with the same speed as the primary light. That means it's same as the wave. Okay, secondary and primary both move at the same speed. When a point source of light is placed at the principal focus of a thin convex lens, the shape of the emergent wavefront is. So first of all, this is a thin convex lens, okay, and the source is placed at the principal focus. Okay, so if you put a point source over here, the light after passing through the lens, it will become parallel, right? It will become parallel and it will meet at infinity. That is the property, that is the definition of principal focus, right? So if you put a point object at the principal focus, after refraction they becomes parallel. So for parallel ray of light, what is the shape of wavefront? The shape of the wavefront is also parallel. This is the parallel line, parallel plane. Okay, so this will be like this, parallel plane. So it will be plane wavefront. The wavefront will be plane wavefront. Before incident, it was a spherical wavefront. Before incident, it was a spherical wavefront. So through this method, you can convert spherical wavefront into plane wavefront. Okay, this is one of the method. So it will be a plane wavefront. Okay. Now next, the shape of the wave front for light coming from a distant star. Shape of the wave front for light coming from a distant star. The star is very far. Okay, if the object is very far, the light which reaches our earth, after some time it becomes parallel. So we consider them to be a plane wavefront as well. Okay, even though it's a point object, but because it's located very, very far, the wavefront which reaches our eyes are considered as plane wavefront. So this is also plane wavefront. Clear? Let's move on to the fill in the blanks. A rotating vector used to represent alternating quantities is called. So whenever you are trying to fill in the blanks, always remember, in case you don't have any idea what is the answer, just check the options and make sure that makes a proper sense. Okay, it should make a proper sense. Something will remind you something. If that does not remind you anything, that may not be a correct answer. Okay, so let's see. A rotating vector used to represent alternating quantities is called wave, phasors, wattless current, power, real, virtual. So real, virtual is definitely not answer. Quantities is called power, does not make sense. Okay, vector and power does not make any sense. Wattless current again does not make any sense because we are talking about alternating quantities. Okay, either wave or phasors could be an answer. Now wave is not possible over here because we are talking about alternating quantities. Okay, so that itself is a wave. So the correct answer is phasor. Okay, and as soon as you answer one, try to mark it so that you remember. Next, the current through an ideal inductor is called. So we have seen there was one current term over here, wattless current. So even if you don't know that we are talking about current, that means the answer should have something related to current. So that means it will be wattless current. Okay, so the current through an ideal inductor, because it does not consume any power. Ideal inductor, ideal capacitor, they do not consume any power. That's why the current through them are called wattless current. The image formed by a simple microscope, so either it will be real or it will be virtual. Okay, the image formed by a simple microscope means only one lens, and simple microscope only forms virtual image, virtual, erect and enlarged. That's why it is a virtual image. Reciprocal of focal length is called power. Reciprocal of focal length is called power of that lens, power of a lens. Okay, next, phenomenon of polarization proves the dash nature of waves. Again, so this has waves, so the answer should contain something which similar to wave. So phenomenon of polarization proves the wave nature of light waves. Okay, clear? Now let's move on to the next chapter. Now we will be solving questions from chapter wise, one after another. First chapter is current, alternating current, or we call it AC, right? So let's start with the questions one by one. So first question is, what is the transformer? Explain its working. Okay, so a transformer, for many purposes, it is necessary to change or transform an alternating voltage from one to another greater or smaller value. This is done by a device called transformer. So you can say that transformer is a device which can transform or change the alternating voltage. Okay, transformer is a device which is used to transform or change an alternating voltage. It is only possible for alternating voltage, not any voltage can be changed. Next is, transformers works using the principle of mutual induction. Transformer works using the principle of mutual induction. When flux linked with the primary coil changes, an EMF is induced in the secondary. Okay, this is the basic working principle. You don't need to explain NS, NP. If you want, you can do that, but otherwise this is the basic simple explanation and definition of transformer. You can add the diagram of transformer for enhancing your answer. Now next, mention 3 sources of power loss in a transformer. So that's, as I mentioned, actually in your board exam, if you see the blueprint, from this chapter only 2 short question, that is 1 marker, and 1 numerical will come. Okay, but in your FA2 exam, there is a possibility that there will be a 2-3 marker question coming from this chapter. So either 3 sources or 2 sources of flux leakage. These 2 questions are the most common question from this chapter. Okay, so you should practice at least these 2, and these 2 questions, there is a high chance the flux leakage question is the most important. The flux, how power loss happens in a transformer. Okay, so that is one of the most common question in the from the chapter. So what are the power loss? First is flux leakage. There is always some flux leaked. That is, not all flux due to primary passes through the secondary. We know that in the mutual inductance, okay, the flux that is coming out of the primary should cross the secondary, and that's how the induction happens, right? And in ideal cases, we assume that 100% flux coming out of the primary is actually linked with the secondary, but actually in practicality that is not the case. So that's why we lose some efficiency. Okay, resistance of the windings, the wire used for the windings has some resistance, and so the energy lost due to heat produced by the wire. So we know that heat produced in a wire is given by I square R into time. Okay, so this is the power, and if you multiply with time, we get the lost energy. So I square RT, that's why we lose some power, and that depends on the resistance, proportional to resistance, right? Higher the resistance, more power it is lost. We generally use copper windings. Copper is tend to have smaller resistance, but still that is not 0, right? Eddy currents, the alternating magnetic flux induces eddy current in the iron core and causes heating. The effect is reduced by using laminated core. So remember this this also comes as a MCQ question. Okay, so eddy current is a way of developing current when the flux that is linking with the secondary. Okay, you have a transformer core, right? There is a transformer core. This structure is called transformer core. Okay, so here we have a primary, and here we have a secondary. Okay, so here we have a resistance, here we have the AC source. Now the core is made of metal, so that maximum flux can be linked with the secondary, so there is flux leakage is less. Okay, if you use any other structure, for example wooden structure, this will not be helpful to increase the flux linked. Okay, flux linked will only depend on the space, it will not depend on the core itself. Okay, so, and we know that it proportional to mu. So mu for iron, soft iron is generally high, that's why soft iron is used. But while doing so, the flux which is coming out of this primary also gets linked with this secondary iron, okay, and that's why there will be some internal current developed in the iron core. So the iron core will also have some current which is passing like this, okay. This current is called eddy currents. This current is called eddy currents, and as current passes through this iron core, the core gets heated up. Again, same principle, I square RT. So because current is passing through the soft iron is not having a high resistance, so it heats up very quickly. So to avoid that, to reduce that, you cannot avoid it, to reduce that, when the core is developed, okay, core is a three-dimensional figure, okay, they make small laminations inside this core, okay, so that the eddy current effect can be reduced, okay. If you open a transformer, the older generation TVs, radios, etc. generally used to have a transformer inside it. So if you have one non-functioning TV or radio, you can open it up and you can find a transformer and you can check, okay. So these are the three main power loss in transformer. Any two might come, or three of them also might come. So you have to remember all these three. Next is numerical questions. From this chapter, as I mentioned, the numerical questions are very important. An AC source of frequency 50 Hz is connected in series with an inductor of 1 Henry, a capacitor of 90 microfarad, and a resistance of 100 ohm. Does the current leads or lags the voltage? Calculate the phase difference between the current and the voltage. First of all, you have to answer whether the current leads or lags. Second, you have to calculate the phase difference, okay. So how to do that? First stage, in case of phase difference, in case of impedance, etc. related questions, first stage is to calculate XL and XC. What is XL? XL is given by 2 pi F into L. Now remember, whenever a numerical question is coming from this chapter, you need to have your calculator ready, okay. The values are not given generously to for you to solve without calculator, okay. They also want to check you if you are good with calculator or not, so you have to use calculator to calculate the values, okay. Obviously there is a pi involved. The main reason is this. Also in case of XC, we will see the value generally is not very pleasant. So 2 into 3.14 into 50 into 1. The inductor is 1 Henry. So one thing you can do, first stage, whenever you are solving a numerical, try to write what are all the given values. L is equal to 1 Henry, okay. C equals to 90 microfarad. Microfarad means 90 into 10 to the power of minus 6 farad. Okay, resistance is given here as 100 ohm, and the frequency is given as 50 Hz. So always try to write the given data. That will help you whenever you are answering the question, when you are applying the formula, okay, you can easily recall it. Otherwise, every time you have to read the question and put in the values. Okay, so this is one trick that you can use to optimize your solution. I will not say minimize, but optimize your solution. Okay, so now let's see. So it will be 50 into 2 is 100, 100 into 3.14 is 314 ohm. So XL is calculated. Next stage is to calculate XC. What is XC? XC is 1 upon 2 pi F into C. 1 by 2 pi F into C. Now here I always tell you a trick that you can use. So first of all, C is given as 90 into 10 to the power of minus 6. So you have to write entire quantity in the division. Okay, so division of 10 to the power of minus 6 means you can write 10 to the power of plus 6 in the top, right? So 1 upon 10 to the power of minus 6 equals to 10 to the power of 6, right? So this trick we will use to save some time. What about other terms? Other terms will remain as it is. So 2 pi F is 50 and C is 90. Okay, so this 10 to the power of minus 6 term goes up and becomes plus. Okay, now we will try to simplify. We will see that it is 10 to the power of 6 divided by 2 into 50 is 100, 100 into 90 is 9,000, 9,000 into 3.14. Okay, so 3 zeros cancelled and you get 10 to the power of 3 divided by 9 into 3.14. Okay, so 3.14 into 9, 36, 3, 9 ones are 9, 2, 12, in hand 1, 3 9 27, 28.26. Okay, so you will get this around 1000 divided by 28.26. Okay, and this will be approximately so you can take this as approximate. I am taking the approximate value, you can take the exact value, so it will be 35, approximately 35. Okay, if you take the approximate value, it should be around 35 ohm. Okay, so now what we have to do, we have to calculate the which one is leading, voltage or current, which one is leading, current leads or lags the voltage. That is the first question. So as we can see that XL is greater than XC, right? XL is 314, XC is only 35. That means XL is greater than XC, so that definitely means that it is an inductive circuit. So the circuit is inductive, and an inductive circuit means voltage is leading, current is lagging. So I lags V. You should write it in terms of complete terms. Okay, you should write it in terms of complete terms, saying that current lags the voltage. Okay, I used shorthand, but you should not do that in the exam. Okay, because teacher may get confused. Okay, no confusion. Now what is about the phase difference? Phase difference phi is given by tan inverse XL minus XC by R. Now remember, in case you find XC is greater than XL, then you should reverse the terms. That's it. The one thing that you have to remember, if XC is greater, then it will be XC minus XL. This is general formula. If most of the cases XL will be greater, and if XL is greater, XL minus XC by R, done. But in some cases you might find XC is greater, so in that case XC minus XL you have to do, and what will change? The current will lead in that case. Okay, so now let's put the value. Tan 314 minus 35 divided by 100, so it will be tan inverse 2.79. approximately this will come. And if you can use tan table, sin cos tan table to find the exact value of this, otherwise you can leave the answer over here, and this will turn out to be 70 degrees for this particular problem. I remembered it, I wrote it. Okay, in simple calculators you will not be able to calculate the tan inverse value. Scientific calculators are not allowed. Okay, so correct answer is 70 degrees. Okay, but if you don't know, you can leave the answer over here, you can mark the answer over here, okay, and you will get the full marks. Maximum they will deduct 1 mark, but that is a rare chance. Most cases you will get the full marks if the value is not of the standard result. Standard result means 1 by root 2, root 3, 1 by root 3, 1. Those are standard values. 0, infinity, those are standard values for tan inverse. Right, now let's move on to the next question. A sinusoidal voltage of RMS value 200 volt and frequency 50 Hz is applied to a series RC circuit. So here we have only resistance and capacitance, no inductor, okay, in which R is given by 3 ohm and C is given by 800 microfarad. Impedance of the circuit and current through the circuit. Also phase difference between the current and the voltage. So again, given first stage, given what is the given data, frequency is 50 Hz, okay, resistance is 3 ohm, and the capacitance is 80 microfarad. Micro means again 10 to the power of minus 6 farad, and the voltage is also given over here, that is 200 volt. Okay, so these are the given values, and as I mentioned, because they ask you impedance directly, so what you have to do, first stage is to calculate XC. No L over here, so only XC is sufficient, and the formulas are again 1 by 2 pi F into C. Formulas are repetitive, that's why I recommend this chapter as one of your go-to chapter for solving numericals. If you practice few numericals, you will be strong enough to solve all the questions. Just you have to overcome the fear. You have to, even if you are solving the same question, stop, pause this video, try to solve it on your own, and then check the solution. That is one of the way to learn alternating current. Alternating current chapter is very easy. As I mentioned, you might need to use calculator for some problems, otherwise the problems are relatively easy. Same formulas coming again and again, okay, in one format or another, but that can be used to solve all the problems. Okay, so again 10 to the power of minus 6 are there, so we will put that in the top as I mentioned. So these are the steps you have to be careful. 2 pi F, 2 into pi into 50, F is 800. Okay, now let's see, 10 to the power of 6 is there, 1 2 3 zeros already cancelled, so we got 10 to the power of 3 divided by 2 into 5 into 8. Okay, 2 into 5 is 10, 10 into 8 is 80, so 80 pi. Okay, so again one more zeros cancelled, and we got 10 to the power of 2 divided by 8 pi. Now 8 pi is what? 8 pi means 8 into 3.14. So this will be 3 8s are 24 plus almost 1.02, that is 25. Okay, so you can take 8 pi very close to 25, and we will take that, so it will be 100 divided by 25, and that will be equals to 4. So the XC value we have calculated as 4. Okay, first stage is done, but this is not an answer. Okay, answer we have to calculate one by one. First stage is to impedance of the circuit. So what is the formula for impedance? Impedance in general is formula is R square plus XL minus XC whole square. This is the general formula. But here there is no XC, so you simply put 0 instead of there is no XL, so you just simply put 0 instead of XL. So 0 minus XC whole square, that is simply XC square. Okay, so we will get R square plus XC square, R square plus XC square. Okay, if you remember one formula, you can solve all the questions. Okay, so now let's put the values. R is 3 square, XC is 4 square, 3 square plus 4 square is 9 plus 16, 9 plus 16 is 25, 25 square root is 5. This is one of the oldest Pythagoras theorem based problems that you have solved, right? 3 square plus 4 square square root is 5. So impedance is 5 ohm. In unit of impedance is ohm. Okay, so first question is solved. This is part A. First answer is solved. So you got some marks for you. Next, the current through the circuit. So how to find the current? Current through the circuit is voltage divided by impedance. Okay, so voltage is given in this question 200 volt, and impedance we have calculated as 5, so it will be 40 ampere. So current in the circuit is 40 ampere. And last but not the least, so this is part B. So this one is also done. Phase difference between current and voltage. Phase difference between current and voltage, we already saw the formula tan inverse XL minus XC, but because there is no XL here, we will simply take XC by R. Okay, negative sign we will always avoid inside the symbol. Okay, inside the tan inverse we will always avoid the negative sign. Clear? Tan inverse 4 by 3, which will be, I think, equals to 53 degrees. Again, if you remember, know it, you can put it. If you don't know it, you can keep it as it is. Okay, this is one of the semi-standard angle which is important for JEE exams. So that's why students tend to remember this value. If you don't remember it, that is also fine. Okay, 4/3 is 53-degree angle. So this is your answer for C. Okay, so all the answers are done. 5 ohm, 40 ampere and 53 degrees. Next question. A resistor of 200 ohm and capacitance of 50 microfarad are connected in series to a 220 volt 50 Hz AC supply. Calculate the current in the circuit and phase difference between the current and the voltage. Almost same question. Only thing, they have not directly asked you to calculate the impedance, but because they asked you to calculate the current, that means you have to calculate the impedance as well. So first, again, whenever you see such questions, start writing with given. Resistance is 200 ohm. Okay, capacitor is 15 microfarad. That is 15 into 10 to the power of minus 6 farad. Okay, voltage is 220 volt and frequency is 50 Hz. They generally will always give you frequency equals to 50 Hz. Okay, except in competitive exam. So first stage, again, because it's again a capacitor, so if it is coming generally XL, RC's RL circuit tends to be little easier. So if they are giving only two options, RC circuits are more common, or they will give you direct LCR circuit. We have already solved one question, and impedance formula also we have learned, right? So this is all the formulas that you need to know to solve any questions from this chapter. So XC is 1/2 pi FC. Also you get part marking if you even calculate one part. If you make some mistakes in some future options, then it's still you should get some marks. Okay, so 100 pi into 15 10 to the power of 6. Why 100 pi I have written? Again, this is the thing that you should remember. If 50 Hz is given as frequency, 2 pi is always 100 pi. 2 pi f. 2 pi f always becomes 100 pi. Okay, remember it. If you can, you can. Otherwise, no need. But if you can, it only helps you to eliminate some of the values. Okay, so 0, 0 cancels, and you get 10 to the power of 4 divided by 15 pi. Okay. So this will be 3 5s are 45. 45 plus 46, approximately 47. So 10 to the power, I am assuming 50. Okay, no need to assume anymore. You can use your calculator to solve it, but I don't like to use calculators, and I don't have a calculator with me right now. So that's why I am using simple value, which is 50. Okay, which I can cancel, that's why I am using. Okay, so you get 200 ohm as your XC. Okay, so XC value is calculated. Now you have to calculate the impedance. Impedance again, R square plus XL minus XC, but because there is no XL, so simply XC square. So this will be 200 square plus 200 square, which will be 200 root 2. Again, this is not exact value. You should use a calculator to calculate the exact value, right? So this will be equals to 200 into 1.4. That will be 280 ohm, approximately 280 ohm. Okay, so what is the current? Current in the circuit is given by voltage divided by Z, that is 220 divided by 280. Okay, and what is the phase difference? I will tell you the answer, but first let me write everything. Phase difference is tan inverse XC divided by R. So this is tan inverse almost 200 divided by 200, that is 1. So approximately 45 degrees. Now let's see the exact answer. Exact answer is 0.75. If you put the exact values, you will get 0.75 ampere, and this will turn out to be 46.6 degrees. Okay, as you can take this much leniency on me, right? I am working hard over here, so, and without using a calculator, so I hope you will forgive me to not give you the exact values, but you have a calculator. If you want, you can immediately calculate this value, 10 to the power of 4 divided by 15 pi, and then 10 to the power of 4 means 10,000. Okay, 10 to the power 3 means 1000, 10 to the power 2 means 100, 10 to the power 1 means 10. Okay, so 10 to the power 4 means 10,000 divided by 15 pi, and you can calculate the value, and then you can calculate Z and phi. Okay, now let's move to next chapter, electromagnetic wave. This is the smallest chapter, so it will not take much time, so we will cover it quickly. Right, two uses of ultraviolet radiations. UV radiations can be focused into narrow beams for high precision applications such as LASIK operation for eye. Okay, if you are suffering from eye aberrations like me, you can do an operation like LASIK and repair your eyesight. Then you will not be needing any glasses. UV lamps are used to kill germs in water purifiers. So you have seen UV, RO, right? RO UV. So RO UV is a device which basically kills all the germs present in water. So that is one of the application of UV. It is also used to sterilize milk. It is used to sterilize the operation instrument. Okay, OT, operation theater instruments. Okay, for example, someone has to get operated. Okay, maybe there some disease happened in their body and it has to be removed. So the instruments that is used in that operation procedure, those are passed under UV. Even if they are 100% clean, they are passed under UV to kill any germs that might present. Next, name the electromagnetic waves used for following applications: the radar system used in aircraft navigation, the remote switches of household electric systems such as TV. So you have seen, right, in movies, radar system is working like something is rotating like that. So what is the frequency of light? It is not only used in radar of aircraft, it is also used in sonar. Okay, so the answer for this is microwave. Microwave is used in radar, microwave is used in sonar technology as well. Sonar technology are used in underwater to detect if there are some enemy ship is present, any underwater mountain is present, or some fishes are there or not. So those are used by microwaves. And infrared waves. Infrared waves are also used for remote control in TV. Okay, so remote control, if you are using a remote control in your TV, that basically is a infrared light. What is displacement current? Give the expression for it. So as I mentioned, displacement current, and not only displacement current but also the modified Maxwell Ampere's law, that is also important. Okay, I have discussed that in the objective question, that's why it is not included over here. Same expression, you just need to write the expression. Okay, displacement current, the current due to changing electric field. Current due to changing electric field. So this is the changing electric field is called displacement current, right? So displacement current is given by epsilon naught d phi E by dt. Clear? Next, what are electromagnetic waves? How are they produced? So according to charge produced mutually perpendicular electric and magnetic field, accelerating charge, sorry, not according, what I am saying. So accelerating charge produces mutually perpendicular electric and magnetic field. Okay, so when the charge is accelerating, it automatically produces mutually perpendicular electric and magnetic field. So they are mutually perpendicular. So electric field is suppose in this direction, magnetic field in the upward direction. Okay, this combination of mutually perpendicular oscillating electrical and magnetic field is called electromagnetic wave. So basically what happens? So when the electric field is varying in this direction, okay, varying electric field produces varying magnetic field as well, and in turn varying magnetic field will also produce varying electric field. So they keep on producing each other, and that's how they start progressing. Okay, so electric field produces magnetic field produces electric field only when they are changing. Okay, static electric field cannot produce magnetic field, static magnetic field cannot produce electric field. So be aware of it. How they are produced? Accelerating charge produces electromagnetic wave. Okay, when the electrons accelerate, they produce electromagnetic wave. So what are the possible process? So when an electron is jumping from higher energy to lower energy, we know that, right? It produces a light. We have learned in atomic model chapter. Okay, so when electron is jumping from higher energy level to ground state, it emits an electromagnetic wave. So that is basically an accelerating electron. Okay, so the accelerating electron, when it jumps from two different energy band gaps, it produces a electromagnetic wave. Now last question, mention any two uses of infrared rays. Electronic devices such as LEDs uses infrared and are widely used in the remote switches of household electronic systems such as TV sets. Infrared lamps are used in physical therapy. It is a very good heating mechanism. Okay, and also all heated objects produces infrared radiation. For example, we are also producing infrared radiations. Okay, if you want to observe any object which is producing infrared rays, you need an infrared goggle. Okay, and that is also, infrared goggles are used by army to detect any terrorist they are crossing the border or doing some unwanted activity in the jungle. So that's how the army gets to know. Also infrared surveillance drones are there, infrared satellites are there in the sky through which they can detect infrared motion. Okay, and it is very popular in movies also. They have given a lot of movies where they detect what people are moving through the jungle and some infrared drone is going on and they are tracking it. But even though that is not 100% accurate, but the concept is correct. Infrared goggles are being used by army and intelligence team to track some activities which should not be happening. Right? Now let's move on to the next chapter, ray optics. Now let us move with the next chapter, ray optics. First question again from this chapter, we can expect questions that might come 2-3 marker questions as well as 5 marker long answer type, 5 marker numericals. Both are high chances of coming from this chapter. We will practice everything, don't worry. Some colleges do prefer to give obviously alternating current, there will be a 5 marker question. If you want, you can skip the numerical questions from other chapters if you are confident that I can solve alternating current questions. But if you want an other option as well, in case alternating current question is a little difficult, then you should practice ray optics. Anyway, you have to practice ray optics numericals because that is also important for your final board exam, right? So final board exams, I recommend ray optics chapter is also should be as your backup. So you should practice numerical questions because this chapter is important for numerical questions. Now give the Cartesian sign convention used to measure distances and heights in spherical mirrors. Okay, so first of all, we know that spherical mirrors are obviously any object which is given on a left hand side is negative, anything which is on a right hand side is positive. So first of all, you have to you have to draw the diagram for this question. Only drawing the diagram is not sufficient. You have to mention this is as origin and this as your y-axis. Okay, anything along positive y-axis is positive, anything along negative y-axis is negative, anything along positive y-axis is positive, and anything along negative y-axis is negative. Okay, so this you have to mention along with the diagram, then you will get full marks. That's it. Okay, you don't need to over explain. Okay, object distance is negative, image distance can be negative, can be positive, etc, etc. No need to do everything. Okay, also incident light direction opposite, that is also not required. Okay, Cartesian sign convention is very easy because it uses the geometric coordinate system. That's why it is called Cartesian system, because the geometry of x, y and z is actually developed by Cartesian. Cartesian is the name of the mathematician who developed this geometry, okay, and on his name this is called Cartesian sign convention. So anything along positive x-axis is positive, anything in the negative x-axis is negative, anything along positive y-axis is positive, and negative y-axis is negative, same as your geometry, okay, x comma y, the same thing that you can write it for this system as well. Now next question, show that the focal length of a spherical mirror is equal to half of its radius of curvature, okay. Show that focal length of a spherical mirror is half of the radius of curvature. So first stage is to draw this circuit, this ray diagram. This is compulsory to draw, and remember I have seen many students doing lot of different diagrams. The angles you have to remember is that this is the angle of incident, a parallel ray of light which is falling on the mirror, and it is passing through the focus. Any ray which falls parallel to the principal axis, it should definitely passes through the focus of the mirror, okay. So parallel ray falling on the focus, and it is crossing through the focus, and if you join the center of curvature, and the point of incident, you should get the normal, right? Point of curvature, it is always a normal at this point. So that means this angle is angle of incident and this angle is angle of reflection. So angle of incident is equals to angle of reflection, okay, and combined this total angle, combine the total angle here is 2 theta. Okay, so if this angle is 2 theta, then you can consider this as parallel lines. This line and this line are parallel. This is the bisector. So this angle should be opposite angle or alternate angle. So this angle will also be 2 theta. Similarly, you can take this as your parallel line. These two lines are parallel. This is the bisector. So these are alternate angles. Alternate angles are again equal. Okay, so that means this will again be your theta. This angle is theta. This angle is 2 theta. That is the minimum requirement to remember in the diagram. And you have to mention these things. Now what? Now you have to take two triangles. One is CMD, okay, from triangle CMD, okay, from the triangle CMD, what we can say, this is a triangle, right angle triangle, okay, this is a perpendicular that is drawn from M to D, okay, this is a perpendicular. What about this angle theta? So tan of this angle we have to take, tan theta. What is tan theta? Tan theta is given by base by perpendicular by base, okay, perpendicular by base. So perpendicular is MD and base is CD, okay. So tan theta is MD by CD. Clear? So it will be MD by CD. Next we have to take the second triangle MFD from triangle MFD, okay, MFD. So here again we will take the tan of the angle, but here if you see, here we do not have theta, we have 2 theta. So tan 2 theta equals to MD by FD. Okay, tan 2 theta equals to MD by FD. Now here we will use two very important things. First of all, paraxial ray approximation. What is paraxial ray? Paraxial ray means this ray is very close to the pole of the mirror, okay. That means this distance is very less, okay. This is one of the things that we do for all mirrors and lenses. We always consider paraxial rays. Paraxial ray means even though this distance appears big, in reality the distance is very small. It is only drawn to so that people can understand it, but in reality if you draw a very close ray to the principal axis, you will not be able to see it clearly. The ray diagram will not be able to draw. So that's why it is drawn like that. For paraxial rays, so what is paraxial ray? Paraxial rays means where the ray of light is very close to the axis. Clear? So for paraxial ray, what is the condition? That the theta is very small. So theta is very, very small. Okay, so theta is very, very small for paraxial ray. Okay, so if this point is very close, then the angle will also be very, very small, right? So if you can imagine a line which is very close, so this angle will be very small, theta, right? So we can say that, so for paraxial rays theta is very small, so tan theta should nearly be equals to theta, and that is equals to MD, and divided by, instead of writing CD, we will write CP. Okay, why? CD nearly equals to CP. For paraxial rays, again the ray is very close, that means the point M is very close to the point P, and D will be almost same as P. Okay, so this is what two approximations we have done. First of all, for paraxial rays theta is small and CP is equals to CD. Okay, similarly from this angle, from this is from equation say 1, and say this is equation 2, from 1 we got this, and from 2 what you got? Tan 2 theta should nearly be equals to 2 theta. Again theta is small, so 2 theta will also be small, even if it's double. So anything multiplied by 0 is always 0, right? Does not matter. So anything smaller, if you even if you multiply with 2, it is not very large. Okay, it will be MD by FP. MD by FP. Again same approximation, that we have assumed that FD is very, very close to FP. So if you're still wondering how these equations came to be, we use the triangle law of perpendicular right angle triangle. Okay, tan theta formula is perpendicular by base for the bigger triangle and perpendicular by base for the smaller triangle. Okay, that's how we arrived it. Those who are still thinking how sir wrote these equations. Okay, so this is the basic structure. Now everything is done. Now we will put the theta value in this equation, or 2 into MD by CP equals to MD by FP. So we have taken this theta value from this equation and put it in back in this equation. Okay, so now MD gets cancelled, and the cross multiplication we get CP equals to 2FP, FD, sorry, no FP, sorry. So what is FP, by the way? FP, what is F? F is focus, so FP must be focal length, and C is center of curvature, so CP must be equals to radius of curvature, that is R equals to 2F. This is the derivation, or you can write F equals to R by 2. This is the derivation that we are finding for, searching for. Easy derivation, 3 mark guaranteed, and in many cases this question is very, very common in pre-board exam as well as in your FA2 exam. Okay, so do practice this. In board exam this does not came too many times, it came 2-3 times it came, but for pre-board exam and FA2 exam I have seen almost most of the districts they do give this as their question. Now question number 3, write 2 conditions for total internal reflection of light and mention its one technological application. Okay, light must travel from denser to rarer medium. The angle of incidence must be greater than the critical angle between the medium. Okay, so 2 conditions. First of all, light must be traveling from denser to rarer medium. So whenever light is traveling from denser to rarer medium, the total internal reflection will happen. Also the angle of incident must be greater than the critical angle. So this is the 2 conditions for observing total internal reflection. And what is the application? Fiber optics. Okay, optical fiber optics. Optical fibers are the cable used to transfer data using total internal reflection. Okay, so if you are using internet, basically you have a fiber connection at your home, mostly fiber connection. Okay, Airtel fiber or Jio fiber, those are the 2 most common, Act fiber, right? So you use one of them in your home. So that basically uses fiber optic cables to transfer data from one place to another. Okay, so basically when we are transmitting through from our server to your mobile phone, basically it is getting transferred through some fiber optics in between. So because of that, you are able to see me in your mobile or in your laptop. Now let's move on to the next. Derive the relationship between U, V, R and N for refraction through a spherical refracting surface. Now this derivation, even though did not came too many times in board exam, this derivation do come in FA exams as well as in your pre-board exams. So you might practice this for only for this. For board exams, my opinion, this is not that important. Okay, so first of all, the ray diagram you have to draw. There is a spherical refracting surface. Light ray is traveling from a medium of refractive index n1 and it is going to a refractive index of medium n2. The angle of this angle, even though this is not angle of incidence, you have to mark them alpha, beta and say this is gamma. Okay, alpha, beta, gamma, these are the three angles. You can mark them ABC as well. Okay, if you are confused, let me instead of marking alpha, beta, gamma, some students get confused, let me mark them with some familiar A, small a, don't use capital, small a, small b and small c. Okay, because the center of curvature is mentioned over here at C, that's why you do not use ABC, but you can use ABC as well. Okay, no problem. Okay, so let us denote these angles by A, B and C. Now what? Now we will use some properties of triangle. What is the property of triangle? So this is a triangle, okay? This is a triangle NOC. NOC is a triangle, and in the triangle NOC, this small a and small b are internal angles, whereas this capital I is opposite external angle. So in the triangle ONC, okay, I is opposite external angle of A and B, so we can write that I equals to A plus B, right? For a triangle, if there is a triangle is there, okay, suppose this is X, this is Y and this is Z, so this is an opposite external angle. Opposite external angle means if you extend one of the side, what angle you will get, that is called external angle, and opposite means these are the internal angles, and the side which is not common, the angle which is not common, anything opposite to that is opposite external angle, and there is a theorem that can be shown that X plus Y is equals to Z, right? This theorem is there. We have learned it in our 9th or 8th standard class. Okay, so this is the first for ONC triangle. Next, we will go into the triangle of NIC. NIC. Okay, NIC in the triangle NIC. Okay, so NIC triangle. What is in this case? This is in this case R and C are internal angles, whereas B is external angle. Okay, so here the triangle is given like this. Okay, so this is R, this is C and this is B. So this is these two are the internal angles and this is the opposite external angle. So that means B equals to R plus C, or R equals to B minus C. Okay, R equals to B minus C. Okay, so this is the first stage to do. This is one important steps are done. So once this is done, we can move on to the next step. Okay, so what is the next step? Next step is to apply again some tan theta, sin theta we have to calculate, and then we have to simplify. That is the major task. So first is apply Snell's law. Okay, what is Snell's law? Snell's law tells us that N1 sine I equals to N2 sine R. Okay, N1 sine I equals to N2 sine. I am keeping some space. I will use that space depending upon what you are getting. So even though that stage has to come before doing this, so in case you memorize everything, you can do step by step, but if you don't memorize everything, you can use the trick, keep some free space between your derivations so that whatever you require, you can go back and you can derive it. Okay, so first of all, for paraxial rays means the angles are again very small, so you can write for paraxial rays sin I nearly equals to I, sin R nearly equals to R. So put that value. So N1 I equals to N2 R. Okay, so what is I? I is A plus B. What is R? R is B minus C. Okay, so these are the two angles. Okay, so these are the two angles that we have calculated, right? So N1I is equal to N2R. Now what? Now again, the back part that we have to do is to find A, B and C. So how to do that? So for that we have to go back to individual triangles. Now NOM, the triangle that we are using, NOM, again, even though this is a perpendicular for paraxial rays, this point is very close to this point, so we will take this as our point M. It will not change, and we will take tan A. Tan A nearly equals to A. We will use this directly. Tan A nearly equals to A, and what is tan A? Perpendicular by base. Perpendicular is NM divided by base. What is base here? Base here is OM. What is OM? OM is nothing but the object distance U. Okay, OM is nothing but object distance U. Next we will go to tan B. Tan B nearly equals to B, and that is equals to, what is tan B? Now again we will take this triangle, okay, and this is a radius of curvature R, okay, for this surface, NM divided by R, okay, it will be NM divided by R, okay. Next we will take the tan C. So this stage you have to do first. Tan C nearly equals to C, and that is given by tan C. Again we will take this triangle tan C. Okay, tan C is given by NM divided by this. So this is our object distance, which is V, image distance, sorry. So it will be NM divided by V. Now we will put these values over here and simplify. That is the steps that is left. Okay, so now let's put these values. So N1 into A plus B. What is A? A is NM divided by NM divided by U. Okay, NM divided by U plus B. What is B? B is NM divided by R, and that is equals to N2 into B minus C. What is B? B is NM by R minus C. C is NM by V. Okay, and as you can see, NM is common in all the terms, so we just need to take them out and cancel it. So we get N1 by U plus N1 by R equals to N2 by R minus N2 by V. So let's take all the R related terms in the same side, U and V related term in the other side. We get N2 by V plus N1 by U equals to N2 minus N1 by R. Now here one thing that you have to do, I forgot to do it, that is U will be negative over here. That I forgot, so it will be one negative sign over here. Okay, why it is negative? Because U is coming on the left hand side. U is coming on the left hand side, so that means it will be negative. So this adjustment you can do anyway during the derivation. Okay, so this will be N2 by V minus N1 by U. So because U is negative, so you have to mention U is negative, because it is on the opposite side of the this is in the negative side, negative x-axis, right? This is positive x-axis, this is negative x-axis. That means object distance is negative according to the sign convention. So this is the equation, this is the general equation for the refraction of light through a curved surface. This formula derivation is not difficult, only thing is the process, and the diagram is very, very important. Okay, in Lensmaker's equation, diagram is not that important. Diagram you have to draw just for doing the derivation, but here the diagram and geometry, because we are using a lot of geometry over here, that's why student feels that this is a difficult derivation. But if you are someone who is very strong with geometry, you should practice it and you should remember it. Okay, now next, derive the expression for refractive index of a material of a prism in terms of angle of minimum deviation and angle of the prism. So this is the one of the another common derivation coming from this chapter. So first of all, these two diagrams are compulsory in this derivation. Okay, so in the first diagram you have to mention angle of incidence, angle of emergence, angle of prism, R1, R2, delta. So this diagram is very, very important. Students only skip this derivation because of the diagram. Otherwise the mathematics and answer is very easy. Okay, because they have to draw the diagram, student keeps it, but you have to practice the diagram. You cannot just simply see it and in the exam you will go and directly draw the diagram. You will make a lot of mistakes. You have to practice the diagram using your pencil and paper. Okay, so practice the diagram. Okay, and again, as I mentioned, if you want to download the PDF of this lecture, join our WhatsApp channel. The link of the WhatsApp channel given in the description section. Also, if you have not yet subscribed, please don't forget to subscribe our channel. Subscriptions are very, very important for us. Right, now let us continue. So this diagram you have to practice 2-3 times so that you are familiar what is I, what is E, what is R1, what is R2. Okay, and the delta. So these are the major things. Also angle of the prism A. This diagram is also important. It's like an U, slightly curved U. Okay, and at this particular point the angle of incidence and angle of emergence becomes equal. So that means at this point what happens is that the angle of incidence and angle of emergence equal. That means this is the position where we get the minimum deviation. So minimum deviation means any graph, if you observe any graph, okay, this is called a minimum point. Okay, this is first minimum, second minimum, like that. Okay, you have done maximum and minimum in your integration chapter or differentiation chapter, right? So minimum is basically the lowest point in a graph. So lowest point in a graph gives the minimum. Okay, so now you have to write from geometry delta. This minimum angle of deviation delta is given by I plus E minus A. Okay, also A is given by R1 plus R2. These things can be proven if you take any one of the quadrilaterals, and if you take the apply the principle of refraction, you can calculate this values. Okay, I1 plus delta equals to I plus E minus A, and A equals to R1 plus R2. Now by observing the I versus delta graph, I versus delta graph is this one. Okay, by observing I versus delta graph, we can see that the angle of minimum deviation, occurs when the angle of incidence I is equal to angle of emergence E. Okay, that is I equals to E. Now if I equals to E, what happens? I is incident angle. R1, R2 are respective internal angles. So if I is equals to E, then this internal angles will also be equal, right? If external angles are equal, then internal angles should also be equal, right? So R1 must be equals to R2. So from there you can put these values back into this equation, and you can calculate delta M equals to 2I minus A. Okay, and I becomes A plus delta M by 2, and A becomes R 2R. Okay, now you can use the Snell's law that says that the refractive index of the material of the prism with respect to surrounding is given by N21 equals to sin I by sin R. So sin I we have calculated, this one is I, so this value you put, and this is R, R is A by 2, put that value and you will get the correct answer. Okay, very simple. Derivation wise not difficult, only Snell's law you have to do, but the geometry part you have to remember. Okay, now next question, deduce the lensmaker's formula. Again, lensmaker's formula, the diagram you have to draw, but the diagram you can solve it even without drawing the diagram, but don't forget to draw the diagram. Diagram is important. Okay, you get 1 marks for the diagram, and if you don't draw the diagram you might get a 0 marks. Okay, so first of all, what formula we will be using? We will be using the formula that we have just derived few moments back, that is the curved surface formula. So first you can consider this as a curved surface. The radius of curvature of this curved surface, say, is given by R1. Radius of curvature of this surface is given by R2. There are two curved surfaces. Okay, one is R1, another one is R2. They may be equal, they may not be equal. Okay, R1 is generally positive, R2 is generally negative. But we will see that. We will not use the sign over here. We will see that. First, what is the formula that we will be using? We will be using that N2 by V minus N1 by U equals to N2 minus N1 upon R. This is the formula that we will be using. Now for the first surface, suppose the image is formed at a distance, say V1. The image is formed at a intermediate distance V1. Now for the first surface, for the second surface, this will act as an object and the final image will be formed at V. Okay, so let's do that. So N2 by V equals to N1 by U, that is equals to N2 minus N1 by R. Now let's use that N2 by V1 equals to N1 by U and N2 minus N1 by R1. This is the first equation, equation number 1. What is the second equation? Second equation, now light is traveling from inside the lens to outside. So light is traveling from N2 to N1. Okay, so we will write N1 by V, because V is located inside the outer medium. Outer medium has a refractive index of N1, right? N1, and this one is N2. Okay, so that's why we will put N1 by V minus N2 by U. Sorry, not N2 by U, what I am saying. N2 by V1. Okay, this was the intermediate distance, so this will now act as the object distance for the second surface. So N2 by V1, and that will be equals to N1 minus N2 by R2. So light was, in the first case, light was traveling from N1 to N2, so that's why here we have N2 minus N1. In the second case, light is traveling from N2 towards N1, that's why we have N1 minus N2. Okay, now we just simply need to add these two equations. Okay, simply add these two equations and we get N2 by V1, N2 by V1 cancels, and we get N1 upon V minus N1 upon U equals to N2 minus N1 1 upon R1 minus 1 upon R2. Okay, so this is the formula. Okay, we have taken 1 minus common, and also or you can write here also minus N2 minus N1. Why we have done that? Because to match n2 minus n1 we have done it. Okay, now what? Now take this n1 common. We got 1 by v minus 1 by u equals to n2 by n1 minus 1 upon r1 minus 1 upon r2. So this is the formula. Now this is not the focal length. Okay, you can use length equation, but I generally don't prefer to use length equation. So what we will be doing? We will say that for u equals to infinity, v equals to f. So if an object is located at infinity, that is parallel beam of light is falling on the lens, then the image formed exactly at the focus. That is the definition, right? For an object which is at infinity, that means parallel ray of light falling. Object at infinity means parallel ray of light. So if the parallel ray of light falling on the lens, then it passes through the focus, right? So that's how we will use it over here. So we'll say that 1 upon f minus 1 upon infinity. 1 upon infinity is 0. So we will say n21 minus 1 upon r1 minus 1 upon r2. Okay, this is the lens maker's equation. Okay, so n of 2 divided by n of 1 is n21. So this is the relative refractive index of the medium of the lens. Clear? Now an object of, now we will solve 3 numerical questions. An object of height 1 millimeter is kept perpendicular to the axis of a thin convex lens of power plus 10 d. The distance between the object and the lens is 15 centimeter. Find the position and height of the image formed. So here we have height of 1 millimeter is kept perpendicular. So height of the object is given by 1 millimeter. Don't worry, we will not use it till the last part. Okay, kept perpendicular to the axis of a convex lens of power plus 10d. Convex lens of power plus 10d. Okay, that means focal length is 100 by 10. That is 10 centimeter. Why 100 by 10? Because power is given when focal length is measured in meters. To convert from meter to centimeter, you have to multiply with 100. Okay, that's why. Now what? The distance between the object and the lens is 15 centimeters. So object distance is 15 centimeter. Okay, find the position and the height of the image. So first we have to find the position of the image. So we know that 1 upon v minus 1 upon u equals to 1 upon f. Okay, now object distance is always negative. Object distance will always be negative, but when we are treating the equation, we will not put any negative sign yet. We will put that in the last step. Okay, try to simplify it and we will get v equals to uf by u plus f. If you remember it, good. Otherwise you just do one step. Don't put the values immediately, it might get tricky, but once you get this formula, it is very easy to solve. So v equals to minus 15 plus 10 divided by minus 15 plus 10. Okay, right? So that is minus 150 divided by minus 5, minus cancels, and you get 30. So v equals to 30 centimeter. V equals to 30 centimeter, right? So we have calculated the image distance. Now we have to calculate the height of the object. So to calculate height of the object, we have to calculate the magnification, which is given by v upon u. So v is 30, u is minus 15, that is equals to minus 2. So height of the image will be given by m into height of the object, which is minus 2 into 1, that is minus 2 millimeter. Now what is the significance of minus? Minus represents the image is inverted. Image is inverted. Image is inverted. Okay, so it represents sorry, is inverted. Okay, see the object is like this, then image will be in the opposite side. Okay, now let's move on to the next question. A double convex lens is to be manufactured from a glass of refractive index 1.55 with both faces of the same radius of curvature. Find the radius of curvature required if the focal length is to be 20 centimeter. Also find the focal length of the lens if it is immersed in water of refractive index of 1.33. Okay. So how to do that? First of all, we have to find the radius of curvature required. So what is given here? The refractive index of the glass is given 1.55 and the focal length that we are trying to produce is given by 20 centimeter. So again, this is based on lens maker's equation. So either there is a high chance that lens maker equation derivation or lens maker equation related numerical question will come. Okay, so now let's see what is the lens maker equation says. 1 upon f equals to n minus 1 by r1 minus 1 by r2. Now for equiconvex lens, when both surfaces are equal, okay, for equiconvex lens, r1 and r2 both are equal in magnitude but sign is different. So r1 equals to minus r2 equals to rc. Okay, so if you say that, then we can write this as n minus 1 2 upon r. Okay, 1 will be plus, 1 will be minus, and they will be 2 upon r. Okay, right? So we will write here r1 equals to r2 equals to minus r c, right? So here we will just use it and we will get it is 2 upon r. So r equals to, so do the cross multiplication, we get 2 into n minus 1 f. Okay, so r equals to 2 into n minus 1 into f. So what is 2? N minus 1 is 1.55 minus 1, f is 20. Okay, so 2 into 0.55 into 20. Okay, 1.55 minus 1, so 2 into 0.55 is 11, so 11 into 10, 11 into what I'm saying, 2 into 0.55 is 1.1 into 20, that will be 22 centimeter. So 22 centimeter is the radius of curvature of the lens, right? Now next they are asking also find the new focal length if the lens is immersed in water of refractive index 1.33. So this is option A. Okay, if the lens is immersed in a refractive index of 1.33, what will be the what will be the new focal length? Now we will start with this relation. This is easier relation to handle. Okay, we will use that r equals to 2 into n2 by n1 minus 1 into f dash. Okay, we will start with this relation. This is much easier to handle. Why? This one we already have proven. Only thing that you have to do is that this refractive index is no longer that of with respect to air. So you have to divide by the new refractive index of 1.33. That's it. Okay. Now what? Now we will simplify. So r value we know 22 equals to 2 into 1.55 minus 1.33 divided by 1.33 into f dash. Okay. So what we have done? We have put the value of n2 as 1.55 and n1 as 1.33. So common LCM is 1.33 and we just did the mathematics. So 22 equals to, or we can cancel, we get 11 over here. So 11 okay equals to 1.55 minus 1.33 is 0.22 divided by 1.33 equals to f dash. Okay, or we can say we can 1.33 by the way, 1.33 can approximately written as 4 upon 3. Okay, you can check that. So we will use that fact over here also. So 11 equals to 0.22 divided by 4 upon 3 into f dash. Okay, or you can use the calculator. Okay, but I am not using the calculator, that's why I am using some fancy tricks, nothing else. So f dash equals to 11 into 4 upon 3 into 1 by 0.22. So it will be 0.2. Okay, and you will get 1.33 by 0.2, that will be 0.65, approximately 0.665. Sorry, 66.5. Okay, division by 0.2, that means you have to increase it, it will be 0.665. This will be 0.2. Okay, 66.5 centimeter. Okay, 66.5 centimeter will be the correct answer, right? Now let's move on. Find the effective focal length and effective power of combination of a convex lens of focal length 25 centimeter in contact with a concave lens of focal length 20 centimeter. If the system is converging or diverging lens, ignore the thickness of the lenses. Okay, so what is the given question? This is one of the easiest question. Convex lens of focal length 25, so convex lens focal length 25 and in contact with the concave lens of focal length 20 centimeter. Concave length has focal length negative. Focal length of concave lenses are always negative. They ask you what is the system a converging or diverging lens? Ignore the thickness of the system. Okay, first of all, find the effective focal length. What is the formula for effective focal length? Formula for effective focal length is simple f1 f2 by f1 plus f2. Simple formula for parallel of resistance. Okay, so here only thing that we have to take care of, that you have to put the negative sign, and here we are multiplying, not adding or subtracting. 25 minus 20, so we will get minus 25 into 20 divided by 5. Okay, 25 minus 20 is 5, so 5 5s are 25, 5 20s are minus 100 centimeter. So if the focal length is negative, then it is a diverging lens. It is a diverging lens. Okay, diverging lens means it's a concave lens. Convex lenses are converging, concave lenses are diverging. Equivalent focal length negative means it's a diverging lens. So the correct answer is 100 centimeter and diverging lens. Okay, now next, a double convex lens made of glass of refractive index 1.5 has radii of curvature 20 centimeter and 15 centimeter, is immersed in water of refractive index 1.33. Calculate the change in focal length of the lens. So first of all, here in this particular question, both radii of curvature are not same. Okay, so you cannot use the shortcut formula that we used in the previous problem. So here we have to start with the beginning. First, again we'll start first case. Suppose in the first case, when it is in air, okay, when the lens is in air, the focal length is say is FA. Okay, it is in air. What is the formula? N minus 1 upon R1 minus 1 upon R2. Now remember, the lens is a convex lens, so R2 must be negative. These are the small things that you have to remember, because when you are putting the values, even if you understood the question, even if you are entering the values, I have seen this, ignore the sign. So R1 is 20, but R2 is minus 15. So don't forget that. Okay, R1 is 20 centimeter, R2 is minus 15 centimeter, and that you have to put it over here. So initially the refractive index of the medium is 1.5 minus 1 upon 20 plus 1 upon 15. So normally for a convex lens, this will always be positive. For a concave lens, both will be negative. Okay, so there is a negative sign already there, and R1 will be negative, not R2. R2 is positive for concave lens. Okay, so by default minus, so minus sign goes common. Okay, In case of convex lens, it should always come to be a positive sign in the center. You remember this small tricks, it will be helpful. So 0.5 into 20 into 15 times 20 plus 15. Okay, just did that. So FA equals to 20 into 15 divided by 35 into 0.5. We just take the inverse on both cases. 20 plus 15 is 35. Okay, we have to take the reciprocal because it is 1 by FA, right? So 3 5s are 15, 3 7s are 35, or you get 0.5 goes up and becomes 2. 2 means 40, 120 divided by 7. 120 divided by 7. Just use the calculator, you can calculate the value. So, but as I mentioned, I generally do not use the calculator. 7 1s are 7. Then we have 50, which is 7. So I think it should be 17.1 centimeter. So F1 should be 17.1 centimeter. Now again we have to calculate if in water. Okay, we have to calculate in water. Okay, and that is again given by N of glass. Here it was only glass, right? Here in this glass divided by refractive index of water minus 1 and 1 by R1 minus 1 by R2. Okay, or F water can be written as R1 R2 by R1 plus R2, because as we know both are positive. So this is a shortcut formula that we are trying to develop. Okay, into N water divided by N glass minus N water. This is a shortcut formula that we have developed. After solving this question, we realize we can write it like this, and that's how we have developed this shortcut formula. You can use this formula for any questions. Okay, so R12 is 20 into 15 divided by 20 plus 15. Okay, we have put the R2 itself as minus. That's why we are putting only positive values. Okay. Okay. Now, what about this term? NW is given by 1.33, and here we have 1.5 minus 1.33. So this will be 20 into 15 divided by 35 into 1.33 divided by 0.17. Okay, and we get this as 3.5, and if you calculate it, you should get it about 67.1 centimeter. You can calculate and you can get the focal lengths. Now they asked you what is the change in focal length. Change in focal length means delta F. Delta F is focal length in water minus focal length in air, that is 67.1 minus 17.1, approximately it will come out to be 50 centimeter. Okay, you can use the calculator and calculate the exact value. So this will come out to be 50 centimeter. So this is the end of this chapter. Now we will go into the last chapter of the day, that is wave optics. So let's continue with the last chapter. Two coherent waves of a constant phase. Now from this chapter I am not discussing any short questions. Yes, it will come 2-3 marker question. So what I am doing instead, I am solving few questions as a 5 marker question. So if you see A, B, C, all of these 3 questions can be asked as a 2 marker or 3 marker question. Okay, so these 3 questions are important questions, so they can either be asked as a 2 marker or can be a 3 marker. So let's see, we'll answer them. This question, the first question can be asked as a 3-marker question, and they can be combined with a 2-marker question to make it a 3-marker. Two coherent waves of constant phase difference undergo interference. Obtain the expression for the resultant displacement. So what is this question about? We have two waves, they are falling at the same point, say P. Two waves falling at the same point, say P. Now when they are falling and meeting at point P, their displacement will change. So first wave, so this is say wave number 1 represented by y1, and the second wave is say represented by y2. So oscillation, we know that can be represented by A1 sine omega t. Okay, this is the first oscillation. This is the equation of oscillation. Second oscillation is given by y2 is equal to A2 sine omega t plus phi. What is this? Phi is the phase difference. Phase difference. Okay, or y2 can be written as A2 sine omega t cos phi plus cos omega t sine phi, right? Sin A plus B is formula, we have broken it. Now let's move on to adding them. So net or resultant displacement is given by y1 plus y2. Okay, so if you add these two terms, first of all we have to take all the sin omega t terms common and all the cos omega t terms common. Okay, so we can write them as A1 plus A2 cos phi sin omega t plus A2 sin phi cos omega t. Okay, so these are the two equations. Now we have to substitute this as r cos theta, or say r cos alpha. Okay, theta is generally for unknown angle, so r cos alpha, and this one as r sin alpha. Alpha is different than phi. Okay, we will substitute them and we can write it as r sin omega t cos alpha plus, you have to write them, by the way, I don't have enough space, so that's why I'm not writing it here. You have to write. Let us substitute A1 plus A2 cos phi equals to r cos alpha and A2 sin theta equals to r sin alpha. So then we can write this as r sin alpha cos omega t. So if you take r common, you will get sin theta, sin A cos B, sin B cos A. So that means sin A plus B omega t plus alpha. Again, this is again our equation of wave oscillation, right, where r represents the amplitude. So if you have substitute them like this, what will be the value of this amplitude? Value of this amplitude is, we have done that in our integration in substitution, right? A sin theta and A cos theta. So what is the amplitude of that? We take square of both of them and add them. So you can do that. You can add the square of these two terms, add them and take a square root, and you will get the resultant value as A1 square plus A2 square plus 2A1 A2 cos phi. This is same as vector addition, right? This is same as vector addition. What about the angle alpha? Angle alpha is given by tan inverse sin by cos. So r sin alpha divided by r cos alpha, right? So what I am doing? R sin alpha is what? R sin alpha is A2 sin phi. So A2 sin phi divided by A1 plus A2 cos phi. Tan means sin by phi, sin by cos. So here also sin by cos, except cos is not alone. Cos as a brother of A1. Okay, these equations are exactly same as vector addition. If you remember, in vector addition, when we are finding the resultant of two vectors, we use the same formula, right? So here also we have arrived at the same equation. So this is the first stage. Second question is mention two uses of Polaroids. Third question is give the condition for constructive and destructive interference. Let's see. Two uses of Polaroids are Polaroids used in sunglasses or car windshields, okay, to reduce the glare from reflected light from roads, from water surfaces, from sun. Okay, camera and photographic filters. Camera and photographic filters are used Polaroids to reduce unwanted light and improve the contrast. Okay, if something is too bright, okay, if you use a Polaroid filter, that reduces the intensity and you get a more sharper and better contrast image. Okay, so higher photography, if you are someone who is interested in photography, you will know that if you generate a interest in photography later on, you will have to buy a Polaroid, okay, Polaroid filter. Constructive interference, bright fringe. For bright fringe, the path difference is given by delta x equals to n lambda. N is 0, 1, 2, 3. Destructive interference, delta x is given by 2n plus 1 lambda by 2. N is equals to 0, 1, 2. Okay, and phase difference is given by 2 pi by lambda into delta x. This is general formula. You put the condition for constructive, you will get the phase difference for constructive interference, and if you put the destructive interference, you get the destructive formula. This is the phase difference formula. Next, state Huygens principle. Using Huygens principle, arrive at the law of reflection for a plane wave. Okay, this is the easiest question. Every point on a wavefront acts as a source of secondary wavelets which spread out in the direction with the same speed as the wave. The new position of the wavefront is the forward envelope or tangent of the secondary wavelet. So if this is a source, light is traveling, all the lights which is traveling same distance, this is called the primary wavefront, and any point on the primary wavefront, they will also give rise to the secondary wavelet, and secondary wavelet will also give you the next wavefront, which is common tangent will give you the next position of the wavefront. Okay, and also the speed of secondary wavelet. These are secondary wavelets. Okay, these are the children of the primary wave. Okay, they are also moving with the same speed as primary wavefront. Okay, next is using Huygens principle, arrive at the law of reflection of the plane wave. So here we have diagram is very, very important. We have a mirror and two parallel rays started at some distance. They had the same phase, but after some time there are some path difference developed, and this ray reached the surface faster. Okay, this, let me draw it a little bit clear. So this ray reached the surface faster, whereas its brother, which is also started same time, it reached at some later time. So by the time the ray reached over here, the second ray reached at this point. Okay, so by the time the first ray already reached the mirror, the second ray reaches only up to this point. Okay, now when the you can consider this as the angle of incident. Now when this is I, by the time this ray reaches the mirror, this ray already gets reflected and this reaches somewhere here. Okay, so this is the angle of refraction, and so this length should be equals to this length, and this will give you I am assuming something like that, this will give you a reflected wavefront. So this is called incident wavefront AB, and this is called reflected wavefront CD. Okay, now you have to, what you have to do, you have to show that I equals to R. Now one thing that you have to recall is that this angle with which the incident wavefront is falling is given by angle of incident I, and this angle is given by R. So the angle of incident, whatever is the angle of incidence, the wavefront will also make the same angle. Okay, that is one of the important principle. So whatever is the angle of incident, the incident wavefront will also make the same angle, and whatever is the angle of reflection or refraction, the reflected or refracted wavefront also make the same angle. Okay, in case of refraction it is refracted wavefront, in case of reflection it's a reflected wavefront. Now we have to take these two triangles and we have to show them they are congruent. How to do that? First of all, this angle is 90 degrees, this angle is also 90 degrees. Okay, the angle with which a ray of light intersect a wavefront, a ray of light always intersect at 90 degrees. Okay, ray of light always intersect at 90 degrees. That is Huygens principle. Tangent, common tangent, if you draw the common tangent means what? Tangent always makes an angle 90 degree with its radius. So you can consider this has to be a radius and this is the common tangent. So that's why it is always perpendicular. Now let's see. So from triangles ABC and triangle ADC. Okay, these two triangles, what we can say is that first of all, ABC equals to ADC. Why? Angle ABC equals to angle ADC. So these two angles are 90 degrees. The distance BC equals to DC. The distance BC equals to DC. Why so? Because the time taken by the light to reach from B to C is same as light, sorry, not DC, my mistake. The time taken by the light to reach from B to C is same as the time taken by the light to reach from A to D. Okay, so BC equals to AD. Okay, BC equals to AD. Okay, as I mentioned that they started with the same time, but during their travel the light ray, first light ray reaches faster, the second light ray was slightly delayed, and by the time the ray touches over here point A, that means the second ray was at point B. Okay, and the time that it takes to reach from A to D, the same time the light from B reaches to C. Okay, that's why CD is reflected wavefront. Okay, so BC equals to AD. This is called this is the distance traveled by the second ray. This is the distance traveled by the first ray after reflection happened. Okay, so BC equals to AD. Now initially you might, if you are watching this for the first time, this derivation, then you might be a little bit frustrated, you might be feeling little difficult, but once you think logically using your head, sit down, let your brain cool down, and once you think logically, you will realize that if the speed of light is v in the medium and time taken for both of them are t, then distance travel must be equal. That is mathematics, right? And AC is common. AC is a common side. So we can say that from the combination of side, angle side, the triangle ABC must be congruent to the triangle ADC. So if two triangles are congruent, their similar angles becomes equal. So we can say that therefore angle BAC, angle BAC must be equals to angle DCA. Okay, or what is BAC? Angle BAC is the angle of incident I, that is angle I, and angle DCA is the angle of reflection. So this must be equals to angle of reflection. So this is simple derivation. This derivation is the simplest of the two. The next derivation is obviously state Huygens principle. I already mentioned it. Using Huygens principle, arrived at the Snell's law of refraction for a plane wave. Okay, so here what we will be doing, here we have, this is the question number 3, not 23. Okay, so now we have a ray of light. So again, two rays started same position. By the time the first ray reaches the plane, it is still yet to reach, so you have to draw a perpendicular. So by the time the ray reaches over here, the first ray, second ray is stuck at this point. So this is say A point, this is say B point. Okay, and here what is happening is that the light ray is not getting reflected, but it is going into the second medium. So by the time the ray reaches over here, this ray, original ray, this reaches over here. Okay, the second, the first ray already bends and it travels some distance in the second medium. So this is the incident wavefront. Then this will be the reflected wavefront. Okay, this will be the refracted wavefront. This is refracted wavefront. Okay, now as I mentioned, these angles will always be 90 degrees. So this is 90 degree, this is also 90 degree. This will be angle of incident and this will be angle of refraction. Use a scale, don't draw like me. So these 2 points should match. If you draw using a scale, these 2 points should match at this junction. Okay, now what? Now here these two are different mediums. So this one say has a refractive index N1, this one has a refractive index say N2. This one has a speed of light v1, this one has a speed of light v2. So last case, light is traveling only in one medium, so refractive index was not required, speed was same in both cases. Here light is traveling into two different mediums, so that means refractive, it cannot possible that speed is same, right? Speed is different. So first we will calculate, this is CD. First we will calculate what is the length AC. Length AC. Now time taken, one thing that is common in both cases, the time taken by the light to reach from B to D is same as the time taken for the light to reach A to C. Because the angle is changing, because the speed of light is changing, distance traveled will be different, but time should be same. So same phase means when we say that this is incident wavefront, that means these 2 points have same phase. Okay, same phase. If they have same phase, then only we join them and we say they are they represent the wavefront. So same phase means the time gap has to be maintained. You cannot change the time gap. So if you change the time gap, then it is no longer in a same phase. So here they are maintaining the phase. Okay, they are maintaining the phase means the time taken by the light reach from A to C, the time taken by the light to reach from B to D has to be same. Okay, that's why they must be the refracted ray. Now what is this distance AC? AC is given by speed of light in this medium times the time. What about BD? BD is given by the speed of light in that medium into T. Obviously you don't need to do any congruency over here. Congruency is only for deflection. For refraction, we know Snell's law is sin I by sin R, so we have to go and find sin I and sin R. So this is the right angle triangle. Okay, this is also a right angle triangle. These two triangles are right angle, and we will simply use this fact to find sin I and sin R, then we will divide them. We know that Snell's law, right? So that's how we will do some mathematics. So what is sin I? So this is the angle. Okay, this is the adjacent side and this is hypotenuse. Okay, why this is hypotenuse? This is 90 degree means opposite angle is hypotenuse. So don't get fooled. This is not hypotenuse. Hypotenuse is this one. This is the adjacent side, this is the hypotenuse, this is the perpendicular. Okay, so for sin I it is perpendicular by hypotenuse. Perpendicular is BD, opposite to the adjacent side, right? So it is BD. So sin I is given by BD upon AD. Okay, and here we don't need to do any small angle approximation because sin I can be any value. What about sin R? Sin r here, again this is the angle of refraction, so that means this will be the opposite side, so AC divided by AD. This is 90 degree, opposite side is this is hypotenuse, this is perpendicular, so AC by AD. AC by AD. Now because we already know Snell's law, from that fact we are trying to find the ratio of sin I by sin r, and we will show that this is actually coming out to be the exact Snell's law. Okay, if you had no idea about Snell's law, this derivation could be difficult. Okay, divided by AC by AD. Now AD gets cancelled and we get this as BD upon AC. What is BD? BD is V1T. V1T. What is AC? AC is V2T. Okay, so obviously time gets cancelled and we can write sin I by sin r equals to V1 by V2, or we can write this as C by V2 divided by C by V1. Okay, so this is a simple calculation. You can say that this is division, so if you multiply C1 and C in division, and so what we have done, CV1 by CV2, right? We can do that, multiply C in the denominator and numerator. Now C by V2 we have taken separately, so C by V2 we have taken separately, and what we have V1 by C. Now if you want to write in the same format, you have to invert it, so you get C by V1. Okay, so this is a simple mathematical trick. Now what? So what is C by V2? C is the speed of light in vacuum, V2 is the speed of light in that particular medium. That means this will be the N2, that is the refractive index of that particular medium, and C by V1 will be N1. So if you cross multiply, you will get N1 sin I equals to N2 sin R. So this is the, what is this? This is generalized form of Snell's law, hence proved. Okay, now next we will be solving some numerical. This is the last question, so only 4 questions from this chapter. In Young's double slit experiment, the slits are separated by a distance of 0.5 millimeter. This is taken from your model paper, that's why I am solving it. In Young's double slit experiment, the slits are separated by a distance of 0.5 millimeter and the screen is at a distance of 1.5 meter from the slits. If the distance of the 9th bright fringe from the central maximum is 1.3 centimeter, calculate the wavelength of light used. So what are all the things given? So the distance of the screen, that is capital D, is given as 1.5. okay, the distance between the slits is given as 0.5 millimeter. This is meter, by the way, and millimeter means what? We have to convert it into meter. All the units must be converted into meter, so that means 10 to the power of minus 3 meters. What about the 9th bright fringe? So 9th bright fringe Y9 is given as Y9 is given as 1.3 centimeter. Okay, 1.3 centimeter, that is equals to 1.3 into 10 to the power of minus 2, 1.3 into 10 to the power of minus 2 meter. Okay, these are the facts that is given. Now what is the formula for 9th bright fringes? The formula for 9th bright fringe is given by n lambda capital D divided by small d. Okay, for nth bright fringe the formula is n lambda d by d. Okay, for any nth bright fringe this is the formula. Okay, now here we are talking about 9th bright fringe, so we can write Y9 equals to 9 lambda d by d, and that is given as 1.3 into 10 to the power of minus 2. This is given. Okay, so lambda we have to calculate, so lambda equals to 1.3 into 10 to the power of minus 2 into small d divided by 9 into capital D. Okay, so now put the value. 9D curved glass, right? 1.3 into 10 to the, so if you know what I am talking about, mention that in the comment. So d, small d is 0.5 into 10 to the power of minus 3, and this will be divided by 9 into 1.5, and you will get this as approximately 480 nanometer, right? Let's check. This, if you calculate it, 10 to the power of values, decimals, if you take account of everything, you will get 4.8 into 10 to the power of minus 7. So you can take that as 480 nanometer, okay, approximately violet ray. Okay, so this is the 9th bright fringe. This is easy. Formula, if you remember, you can solve it. Now what about the last part where they have mentioned also calculate the distance of the 5th dark fringe. The formula for dark, this is for bright, by the way. These are the formula for bright. Okay, what about dark? For dark, the formula stands YMD. Okay, I used N for bright, so let me use M for dark. Okay, so YMD, comma D means dark fringe. It is given by 2M minus 1 lambda D by 2 small d. Remember that there is an extra 2 in the numerator as well as in the denominator. Okay, now 5th dark fringe. 5th dark fringe means 2 into 5 minus 1 lambda D by 2d. 2 into 5 means 10, 10 minus 1 is 9. So 9 lambda d by 2d. Something familiar? So if you see here, we have 9 lambda d by small d. But here we have an extra 2 in the division. So what we can do, we can take this half common and we can write 9 lambda d by small d. Now this value is known. This value is 1.3 into 10 to the power of minus 2. So we can say 1.3 into 10 to the power of minus 2 divided by 2. We have to take this half now into account. Only this value is known, half you have to take into account. So you get this as 0.65 centimeter. Okay, 10 to the power of minus 2 meter or 0.65 centimeter. So you get this as 480 nanometer and 0.65 centimeter. I hope this video will help you in score out of out in your FA2, and if you have any other doubts, if you have any other chapters that is going to come in your FA2, please mention that in the comment section below. I'll be back with more videos during your FA2 as well. So till then, bye.